This is the Math 3, Unit 10 review worksheet, and I'm going to work through the odd problems. So part A says use right triangle trigonometry to write a valid equation that will allow you to solve for x. And then solve for x without a calculator. So 54 is our reference angle, this is the hypotenuse, this is the adjacent side, and so the cosine of 54 would be the adjacent over the hypotenuse. Think of that as a proportion, cross multiply, and you get x times the cosine of 54 is 8 root 5 times 1. And then divide by the cosine, you get x is 8 root 5 divided by the cosine of 54. Number 3, our reference angle is 24, so 14 is the opposite side, and x would be your adjacent side. So I'm going to use the tangent of 24 degrees is opposite, 14 over x, which is the adjacent. Cross multiply here, and you get x times the tangent 24 is equal to 14 times 1. Divide by tangent, and you get x is 14 divided by the tangent of 24 degrees. Where 5x is our reference angle, 6 is the opposite, 12 is the adjacent, and so the tangent of x degrees is 6 over 12, which can reduce to 1/2. And then to get x by itself, we're going to use the inverse tangent of 1/2. Number 7, x is our reference angle, 6 root 5 is the opposite, 24 is the hypotenuse. So the sine of angle x is the 6 root 5 over 24. Can reduce that a little bit, divide by top and bottom by 6, so you get root 5 over 4. And then take the inverse of sine, you get x is the inverse sine of root 5 over 4. Number 9, we're to sketch each angle in standard position, identify the quadrant for the terminating ray, and find the reference angle. So 320 degrees is between 270 and 360. So that's in quadrant 4. And the reference angle is the difference between 360 and 320, which is 40 degrees. Number 11, 17 pi over 12 is, well, if we're working with denominators of 12, here's 0. Here's pi, which is 12 pi over 12. And then 2 pi, which is 360 degrees, would be 24 pi over 12. And so 17 is 5 away from 12. And 17 is 7 away from 24. So it's going to be in quadrant 3. Because it's closer to 12 pi over 12 than it is to 24 pi over 12. The reference angle is the difference. Subtract 12 from 17, and you get 5 pi over 12. For 13, 128 degrees is going to be between 90 degrees and 180 degrees. Reference angles here, we're in quadrant 2, and if you subtract 128 from 180, you end up with 52 degrees for your reference angle. 15, here's 0 degrees, moving around, pi is 180, so we're going to write 9 pi over 9, because that's equivalent with a common denominator. And 7 pi is closer to 9 than it is to 0, so we're in quadrant 2. Reference angle is the difference between 7 and 9, so we get 2 pi over 9. Negative 400 degrees. Remember, negative, you move counterclockwise. But, so if you go full circle, that's at negative 360. And go another 90, you're at negative 450. So you're between negative 360 and negative 450 in quadrant 4. And the reference angle is the difference between 400 and 360, which is 40 degrees. Negative 11 pi over 8, you're 0, you're moving negative direction. This is negative pi, which is negative 8 pi over 8. So we're passing that, keep going. At 2 pi or at 360, we're at negative 16 pi over 8. That's equivalent to negative 2 pi. And 11 is only 3 away from 8, where it's 5 away from 16. So it's closer to the 8. So we're talking reference angle is going to be, or the terminal side is going to be in quadrant 2. So here's negative 11 pi over 8. Reference angle is the difference, positive always, between 11 and 8, which is 3 pi over 8. To 32 are to convert each angle from degrees to radian measure, or radian to degrees, whichever is appropriate. Find one positive coterminal and one negative coterminal angle for each of the following. So 21, we're going to convert, and so to make this conversion work, I'm going to say 220 over x is 180 over pi. I'm going degrees over radians is equal to degrees over radians, and we know that pi and 180 are equivalent, and 220 and x are also equivalent conversions. So cross multiply and you get 180x is 220 pi. Divided by 180. Reduce. We can divide by 10. We can divide also by another 2. So we're going to get 11 pi over 9. Positive coterminal angle. It doesn't really state what it wants it in degrees or in radians. Does it? Read it again. Convert each angle from degrees to radian, which find one positive, one negative coterminal angle for each original. So let's look at the original is in degrees, and so I'm going to work with degrees. So to get one positive, I'm going to add 360 to 220. So 220 plus 360 gives me 580. And to get a negative, I'm going to take 220 minus 360 and get negative 140. 23, we're given it in radians. We want to convert to degrees. And so 7 times 180, remember 180 is pi, over 12. And 7 times 180 divided by 12 comes out to 105 degrees. And then we want to get one positive, one negative. So we add 2 pi and subtract 2 pi. Well, remember 2 pi is equivalent to 24 pi over 12. We need a common denominator. So when we add 7 pi with 24 pi, 24 plus 7 is 31. So we get 31 pi over 12. When we subtract 7 minus 24, we end up with negative 17 pi over 12. 25, we got 108 degrees. Sorry, 108 degrees. over converting to x radians, and we know that 180 degrees converts to pi radians. If we cross multiply, we get 180 times x is 108 pi. Divide by 180, you get x is 108 pi divided by 180. So we're just left to reduce here. Both are even, so you can certainly divide by 2, but the 108 and the 180 you can also divide by 4. And keep thinking here, so I'm going to do this. So we got 108. If we reduce it by 4, we get 27 pi over 45. Both of those we can reduce even further. Divide by 9, we get 3 pi over 5. So 3 pi over 5 is what we're after. Add 360 to 108, and you get 468 for a positive coterminal angle. Subtract 360 from 108, and you get negative 252 for a negative coterminal angle. 27, we're given radians, we want to get degrees, so we're just plug in 180 for pi. And we get 8 times 60, which is 480 degrees. Working in radians, we want coterminal angles. We're going to add and subtract 2 pi, but 2 pi is equivalent to 6 pi over 3. So I'm going to take the 8 pi over 3 and add the 6 pi over 3. 8 plus 6 is 14 pi over 3. And I'm going to subtract, well, actually if I subtract I get another positive one, so I'll put it here. You get 2 pi over 3. Keep subtracting 6 pi over 3 from that, and you get negative 4 pi over 3. So I did more than they asked. I came up with 2 different positive coterminal angles. 29, we got negative 450 degrees, and negative 450 converts to x, and that's going to equal 180 degrees, which converts to pi. Cross multiply, 180x is negative 450 pi, x is negative 450 pi divided by 180, just need to reduce. If we divide top and bottom of the fraction by 90, we're going to get negative 5 pi over 2. And let me just highlight that to distinguish the answer. Positive coterminal angle, well, I'm going to take negative 450 and add 360 to it. So 360 plus negative 450 comes out to negative 90. That's a negative coterminal angle. Add another 360 to that, and you're at positive 270 degrees. All are located at the same spot. 31, negative 3 pi over 8, convert that to 180. And so 3 times 180 divided by 8 is 67.5 degrees. Or if you leave that in fraction form, you get 135 over 2 degrees. And we want positive and negative coterminal angles, so we're going to add and subtract 2 pi. 2 pi is equivalent to 16 pi over 8. So if I add 16 with negative 3, I get positive 13 pi over 8. If I subtract, I get negative 19 pi over 8. Number 33, we have to sketch the reference angle, or 33 to 44, sketch the reference angle for each in the correct quadrant, and then find the sine, cosine, and tangent of theta. So in number 33, we have 4 pi over 3. Here's 0. Pi is, or 180 degrees, which is pi, is going to be, I'm going to write as 3 pi over 3. And then 2 pi, or 360, is 6 pi over 3. And so 4 pi over 3 is in quadrant 3. And our reference angle is the difference between 4 pi over 3 and 3 pi over 3, which is pi over 3, which is 180 over 3, which is 60 degrees. So we have a 60-degree angle here, reference angle. I'm going to make this negative 1, negative root 3, and 2. And so the sine of theta, opposite over hypotenuse, negative root 3 over 2. Cosine, negative 1 over 2. And the tangent is negative root 3 over negative 1, which is positive root 3. Number 35, we have negative 7 pi over 4. So here's 0, we're going the negative direction. Here's negative 4 pi over 4, which is the same as pi. Keep going. We got negative 8 pi over 4, which is the same as negative 2 pi. And so we are in quadrant 1. With the reference angle, the difference between 7 pi over 4 and 8 pi over 4, which is pi over 4. Remember, pi is 180 degrees, so 180 divided by 4 is 45. So we got a 45-degree reference angle. So make these side lengths 1 and this root 2. Sine is going to be 1 over root 2. Multiply top and bottom by root 2 to get root 2 over 2. Cosine is also going to be the same. And tangent is opposite over adjacent, 1 over 1, which is 1. 37, 8 pi over 3, here's 0. If we keep going around the circle, we got 3 pi over 3 here. Keep going. 6 pi over 3. Add another 9 pi over 3. So 8 pi over 3 is in quadrant 2. And the reference angle is the difference between 8 and 9, which is pi over 3, which is 60 degrees. So here's my triangle, 60-degree angle. Hypotenuse 2, this is going to be negative 1, this is root 3. So the sine of theta is positive root 3 over 2. Cosine is negative 1 over 2. Tangent is root 3 over negative 1, which is just negative root 3. 39, negative 5 pi over 4, here's 0, moving the negative direction. Here's negative 4 pi over 4, which is negative pi. Keep going that direction. 2 pi is going to be at negative 8 pi over 4. So negative 5 pi over 4 will be in quadrant 2. And the difference between 5 and 4, pi over 4 is 1 pi over 4. Pi over 4 is 45 degrees because it's 180 divided by 4. So we have 45-degree reference angle, make this -1, +1, and √2, because in quadrant 2, x is negative, y is positive. So the sine is going to be +1 over √2, multiply top and bottom by √2. Cosine will be -1 over √2, which simplifies to -√2 over 2. And tangent will be 1 over -1, which is -1. Sorry, you know what? I wrote those in the wrong spot. Let me fix that. Those belong right there. Number 41, we got -11 pi over 6. Here's 0, moving clockwise actually in the negative direction. This is -6 pi over 6, which is the same as -pi. Keep moving, keep moving clockwise. We get -12 pi over 6 at which reduces to -2 pi. So -11 pi over 6 is in quadrant 1. And the reference angle is going to be the difference between 11 and 12 pi over 6, which is pi over 6. Pi is 180. 180 divided by 6 is 30 degrees. So 30, 60, 90. I'm going to make the hypotenuse 2. It makes the opposite side 1 and the adjacent side √3. So sine is opposite over adjacent. Sorry, opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Multiply top and bottom by √3 to get √3 over 3. (43) 7 pi over 4. Here's 0. Moving counterclockwise, we get 4 pi over 4 at 180 degrees, because that reduces to pi. We get 8 pi over 4 at 360, because that reduces to 2 pi. So 7 pi over 4 is in quadrant 4. And the reference angle is the angle between 7 pi over 4 and 8 pi over 4, which is pi over 4. Pi is 180 degrees, so that's 45, because 180 divided by 4 is 45. So we got a 45, 45, 90 triangle. I'm going to make the hypotenuse √2, which makes the legs 1 and 1. But because we're in quadrant 4, I'm going to make the opposite side, or the y value, -1. Sine is opposite over hypotenuse. Multiply top and bottom by √2 to get -√2 over 2. Cosine is adjacent over hypotenuse, which we get √2 over 2. And tangent is opposite over adjacent, which reduces to -1. 45 to 50, we're to sketch each angle and find the sine, cosine, and tangent of that angle. 4 pi, well, here's 0, pi, 2 pi, 3 pi, 4 pi. So 4 pi, if we look at the unit circle, 4 pi is 1 unit to the right of 0, 0. That's at the coordinate 1, 0. And so the sine of 4 pi is your y value of your coordinate, which is 0. The cosine of 4 pi is the x coordinate, which is 1. And the tangent of 4 pi is y divided by x, which is 0 over 1, which is 0. 47, -5 pi over 2. Well, here's 0. Here's -2 pi over 2. Keep going. -4 pi over 2. Keep going. -6 pi over 2. So -5 pi over 2 is right directly in between -4 pi and -6 pi. So it's actually going to be located right here at -5 pi over 2 at the coordinate So it's 1 below 0, 0. So we're at 0, negative 1. So the sine of negative 5 pi over 2 is your y coordinate, which is negative 1. The cosine of negative 5 pi over 2 is the x coordinate, which is 0. The tangent of negative 5 pi over 2 is your y over x, negative 1 over 0, which is undefined. And there we have it. 49, 5 pi, well, here's 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Pi is 180 degrees, so we just keep going half circle until we end up at 5 pi, which is at the coordinate negative 1, 0. So sine of 5 pi is your y coordinate, which is 0. Cosine of 5 pi is your x coordinate, which is negative 1. Tangent of 5 pi is your y over x, which is 0 over negative 1, or 0. Solve for cosine. We get 12 cosine theta is 6 root 3 divided by 12. Cosine theta is 6 root 3 over 12, which reduces to root 3 over 2. In the 30, 60, 90 right triangle, we got side lengths 1, root 3, and 2. And the cosine is adjacent over hypotenuse, so we're looking at a reference angle of 30. So we're looking at 30 degrees in. Now cosine's positive. Cosine is your x-coordinate, which is positive in quadrants 1 and 4. So I'm going to sketch 30 degrees in quadrants 1 and 4. So in quadrant 1, we're looking at 30 degrees. In quadrant 4, well, this is 360, so we're going back 30, so we're at 330 degrees. So theta is both 30 and 330. We subtract 6, we get 4 root 3. Sine theta equals negative 6 divided by 4 root 3. We get sine theta is negative 6 over 4 root 3. We can reduce that a little bit, divide top and bottom by 2, and you get negative 3 over 2 root 3. Then we can multiply top and bottom by root 3 to get negative 3 root 3 over 2 times 3. And then cancel out the 3's, or divide by 3, and you get negative root 3 over 2. Think about your 30, 60, 90 right triangle with the side lengths given. And we want the sine, which is opposite. So we want root 3 to be the opposite. That's the opposite of 60. So we're working with 60 degrees in. Now sine's negative root 3 over 2. So negative y is negative in the quadrants 3 and 4. And so 60 degrees in quadrants 3 and 4. And so this is 180. 80 plus 60 is 240. And this is 360. Subtract 60 and we get 300. So theta is 240 and 300. We get 18 tangent squared theta is equal to 6. By adding 6 to both sides, divide by 18, and you get tangent squared theta is 6 over 18, which is 1 over 3. Take the square root, you get tangent squared theta is square root of 1 over square root of 3, which is 1 over root 3. Think about the 30, 60, 90 right triangle again. With side lengths 1, 2, and root 3. tangent is opposite over adjacent. So 30 is our angle we're after, because if you go opposite over adjacent, you get 1 over root 3. So 30 degrees in, and tangent is positive in quadrants 1 and 3. So 30 degrees in quadrants 1 and 3. Points at 30 degrees, and if this is 180, go add 30 to that and you get 210. So theta is 30 degrees and 210 degrees. By the way, 51 through, it should say, let's see here, 68. Correct that, 51 through 68. So solve each of the following equations for theta such that theta is between 0 and 2 pi. Really, this is asking us to work in radians. And so I've been working in degrees right here. So if you want, you can convert each of these to radians to follow that. Uh, 57. I'm going to add 9, so you get 12 cosine squared theta is equal to 9. Divide by 12, get cosine squared theta, 9 over 12. Reduce that to 3 over 4. Take the square root, you get cosine of theta is equal to root 3 over root 4, which is root 3 over 2. Should be plus or minus. And actually, I need to go back to 55. When we took the square root, it should have been positive or negative, which actually puts us in all 4 quadrants. So I need to correct that. So we could also have 30 degrees in quadrants 2 and 4, which puts us at 150 and 330. So I'm going to add those into our solution. Don't forget that plus or minus. 57, we got plus or minus. Cosine, I'm going to draw my 30, 60, 90 again. Cosine is adjacent over hypotenuse, so I want root 3 to be adjacent. That's adjacent to 30. So we're looking at 30 degrees in all quadrants. So it's going to be the same answer we just looked at. So 30 in each of these. So that's 30, 150, 210, 330. Just like we did back in number 55. '59, it's factored for us, and so what we're going to do is split up our factors. We got 2 tangent theta equals 0, and cosine theta plus 1 equals 0. Divide by 2 on the left hand side and you get tangent theta is still 0. Subtract 1, you get cosine theta is equal to negative 1. So tangent is equal to 0, so we have y over x, remember, is tangent theta. And so that's letting us know on the unit circle our y coordinate is 0. So if we think about the unit circle, where you got those 4 points, which of those 4 points has a y value of 0? Well, we have, this is 1, 0 at 0 degrees. And here is negative 1, 0 at 180 degrees. So both of those are solutions. Cosine is your x value. And so again, on the unit circle, where's x equal to negative 1? Right here. Remember, this is negative 1, 0. And so that's at 180 degrees. So 180 is repeated twice, so we only have to use it once. So theta is 0 and 180 degrees. (61) 2 sine theta plus root 3 equals 0, and tangent theta minus 1 equals 0. So 2 sine theta equals negative root 3. Divided by 2, sine theta is negative root 3 over 2. Tangent here, theta is equal to 1. If we think about our 30, 60, 90, with side lengths 1, 2, and root 3, we want the opposite to be root 3, so that's talking about 60 degrees. So 60 degrees negative, so we're looking at quadrants 3 and 4. So 60 degrees in quadrants 3 and 4. This is 180, 60, 60, 360. So we're pointing at 300 in quadrant 4 and at 240 in quadrant 3. Not done yet. We got the right side to do now. Tangent is equal to 1. Well, that's coming from the 45, 45, 90. Because we got side lengths 1, 1, and root 2. And the tangent of 45 is 1 over 1. So we're looking at 45 in quadrants 1 and 3. Because that's where tangent's positive. So we're pointing at 45 degrees, and if that's 180, we add 45 and get 225. So put all 4 of those together, we got 45, 225, 240, 300. And I am going to skip now down to 69 to 73, it should say. Find the ordered pair in the unit circle for each angle. So 69, we have 5 pi over 6. They're indicating already what quadrant we're in. Remember, 180 is 6 pi over 6, which is pi. 5 pi over 6, somewhere over here. And the reference angle is the difference between 5 pi over 6 and 6 pi over 6, which is pi over 6. Pi is 180, so we get 30 degrees. Okay, and so we're looking for the x and the y coordinate on the unit circle. So think about our 30, 60, 90 right triangle. 30, 60, 90. I'm going to orient the same way. We use side lengths 1, 2, and root 3, which is different than the unit circle because the unit circle has a hypotenuse of 1. So, but that's okay because we know x is the cosine of this angle. Respecting our quadrant, we know that our x value is negative, our y value is positive, and so the x value is the cosine of our angle, and the cosine is adjacent over hypotenuse. The y value is the sine of our angle, and that's opposite over hypotenuse. So our coordinate, xy, is going to be negative root 3 over 2, comma 1/2. For 71, they're telling you it's in quadrant 4 already. So this is where 7 pi over 4 is. Remember, 360 degrees is 8 pi over 4, because that reduces to 2 pi. And so the reference angle is going to be the difference between 8 and 7. Alright, and now so on this one, we're looking for the ordered pair, xy. X is our cosine of theta. Y is our sine of theta. We have our reference angle here is between 7 pi over 4 and 8 pi over 4, which is pi over 4. Pi is 180, so 180 over 4 is 45 degrees. So we have a 45, 45, 90. And if we draw our 45, 45, 90, we got side lengths of 1, hypotenuse at root 2, and we're in quadrant 4, so we're going to make our y value negative 1. So our cosine, which is x, is going to be adjacent over hypotenuse, so 1 over root 2, which is multiply top and bottom by root 2, you get root 2 over 2. Our y value is sine, which is opposite over hypotenuse, so negative 1 over root 2, or negative root 2 over 2. So our answer is going to be positive root 2 over 2, comma negative root 2 over 2. (73). If we have an isosceles triangle and we draw the altitude, it actually cuts that triangle into two equilateral two congruent triangles, both with base length 4. We know the cosine of A from our picture is 4 over the hypotenuse. But it also tells us in the problem that cosine of A is equal to 2 over 5. And so if we cross multiply, we get 2h is 20, h is 10. And we got to our hypotenuse. We're looking for the perimeter, so we know because it's isosceles, we've got 10, 10, and 8. So our perimeter is 10 plus 8 plus 10, or 28 units. For the area, we're going to need 1/2 base times height, so 8 times, and we've got to find the height. I'll call my height y and use Pythagorean theorem. 4 squared plus y squared is our hypotenuse squared. So y squared is 10 squared minus 4 squared. 10 squared is 100. 4 squared is 16. So we get 84. And so y is going to be the square root of 84. Which is 2 root 21. And so half of 8 is 4, times 2 root 21 gives us 8 root 21 square units.